Good day, students. Welcome to Organic Molecules. First, I want to apologize if my background is kind of noisy. So please bear with me, and I hope you will still understand what our lesson is. And there. So organic chemistry and organic molecules are somewhat the same. So I expect that this would be easier for you to understand since you already had a background on organic chemistry back in high school. Now, organic molecules are molecules that are normally found in living systems, and they are usually composed of carbon atoms in rings or in long chains. And these carbons are attached to other atoms such as hydrogen, oxygen, and nitrogen, and so on. Now, atoms are the smallest particle of an element, and it can exist either alone or in combination. So atoms has a nucleus. Sorry. So atoms has a nucleus, and the nucleus consists of subatomic particles, and those are the protons and the neutrons. Another subatomic particle of the atom is the electrons. So electrons is occupying the space of the atom. So it orbits around the nucleus. So an atom has at the nucleus of an atom is a positive charge since it consists of protons, and the space has a negative charge. So this is positive and this is negative. However, overall, the atom is neutral. So wala talaga siyang charge because the number of the positive protons and the number of the negative electrons surrounding the nucleus are the same. Okay? A specific atom, for example, yung ating carbon, ayan. So it is described by its atomic number, which is represented by the letter Z. It gives the number of protons it contains, and the mass number represented by letter A, which gives the total number of protons and neutrons in the nucleus of an atom. So for example, yung ating ngang carbon, ang kanyang number of protons ay 6. Ang mass number niya is 12, meaning yung number of neutrons niya ay 6 din. Kasi 'di ba, 6 plus 6 is 12. Okay. Now, all the atoms of a given element have the same atomic number. 1 for hydrogen, 6 for carbon, 15 for phosphorus, and so on. Pero pwede silang magkaroon ng iba't ibang mass numbers depending on how many neutrons they contain. So atoms with the same atomic number but different mass numbers are called isotopes. Ayan. So for example, meron tayong carbon 12, 13, and 14. On carbon 12, ang neutrons niya is 6. So 6 plus 6, ang mass number niya is 12. Sa carbon 13, meron siyang neutrons na 7. So meron siyang mass number na 13. And sa carbon 14, we have 8 neutrons. So ang magiging mass number niya ay 14. So ganun yan. Okay. So for exercise number 1, give the number of protons, neutrons, and electrons of the following. And gusto ko kayong gumawa ng table just like this. So on the first column, dito yung first and second. Second, meron tayong protons, tas dito naman sa kabila yung electrons. Bakit? Yan. So, ayusin nyo na lang. And dito yung neutrons. Ayan. So, dito sa kabila naman, yun yung mga given. Isulat niya dyan yung given elements, ha? Okay. So that's our exercise number 1. Okay. So most elements found on Earth are mixtures of isotopes. So the weighted average mass in atomic mass units, or AMU, of an element's naturally occurring isotopes is called atomic weight or atomic mass. So for example, we have chlorine. So ang chlorine 35, nag-exist siya naturally 75.77%. Okay? So ang chlorine 37 naman nag-exist naturally 24.23%. So sa chlorine 35, meron daw siyang what do you call this? Atomic mass na 34.97. Tapos ang chlorine 37 naman ay 36.97. Ayan. So ganito siya kunin, i-divide lang yung 75.77% sa 100. Ayan. Times yung atomic mass number. So, ganun din sa chlorine 37. So, we would add those products para magkaroon tayo ng ganitong result. Yung ating atomic weight. Ayan. So, that's how you identify the atomic weight of the isotopes. So, we have this exercise number 2. Calculate the average atomic weight of the following. So, nandyan na yung mga atomic mass ng mga different isotopes. Okay? And the percent ng ng form na nag-exist naturally. Okay. Next. Okay. So, earlier we said that electrons surround the nucleus, or shall we say orbits the nucleus. But how are the electrons distributed in an atom? So may tinatawag tayo na wave function. So it is used to describe the behavior of a specific electron in an atom. And the solution to a wave equation is called wave function or orbitals. So, wave function describes the volume of space around a nucleus in which an electron is most likely to be found. So, ang orbital is a blurry cloud indicating the region of space where the electron has been. So, thus, orbitals represent the space where an electron spends 90 to 95% of its time. So, ano ba yung itsura ng ating orbitals? So, meron tayong 4 na orbitals. Meron tayong s orbitals, may p orbital, may d orbital, with and each has a different shape. Pero I would just discuss the s, p, and the d orbitals. So, the s orbital is spherical with the nucleus at its center. A p orbital is a dumbbell shaped, and four of the 5 d orbitals are clover leaf shaped. So the 5th d orbital is shaped like an elongated dumbbell with a donut around its middle. So I will show you that. I will show you the shape of the d orbitals later. Okay. So, the orbitals in an atom are organized into different electron shells. So, different shells contain different numbers and kinds of orbitals, and each orbital within a shell can be occupied by 2 electrons. So, on the first shell, meron daw siyang, ang capacity niya is 2 electrons. The second shell has a capacity of 8 electrons, and the third shell has a capacity of 18 electrons. So electrons are represented by these red dots or red circles. Okay. So, the first shell, okay, this one, the 1s, the first shell contains only a single s orbital, 1s, okay? So, it is denoted by 1s and thus holds only 2 electrons, okay? So, this arrows, ayan, yung up and down arrow, so yan ay, ibig sabihin, yan is a pair of electrons. Pero kung isa lang, kung up lang yan, ibig sabihin, isa lang yung electron niya. Okay? Now, the second shell contains 1 2s orbital and 3 2p orbitals. Okay? So, ang p orbital, meron siyang tatlong orbital diagram backs or orbital backs. I can't remember. Sa either of the two. So, pag 2p, tatlong orbital boxes. Okay. Now, so the second shell has a capacity of 8 electrons. Okay. So, the third shell contains 3s orbital, may 1s, 3s orbital, isang 3s orbital, tatlong 3p orbitals, at saka may 5 3d orbitals. So, meron siyang capacity of 18 electrons. So, napapansin nyo, nagdadaglag ng dalawang orbital boxes per per shell, per orbital. Okay. So, sa 3s, isang orbital, wait lang. So, sa s orbital, merong isang orbital box. Sa p orbital, merong tatlong orbital boxes, nagdagdag ng 2 boxes. Sa d orbitals, merong 5 orbital boxes, nagdagdag ng another 2 boxes. Okay. So, yung p and d orbitals, they have different types or kinds of orbitals. Okay. So, let's have the shapes of 2p orbitals. So, we have different p orbitals. Each p orbital holds 2 electrons. So, thus, its maximum holding capacity ng 2p orbital ay 6. Okay? Maximum capacity ay 6. So, mapapansin nyo na the orbitals has 2 lobes. Ayan. And these lobes have different algebraic signs. May positive at saka negative. Kaya magkaiba yung color niya. So, ayan. So, sa 2px orbital, nakalay siya, yung orbitals nakalay siya sa x-axis or dun sa ating horizontal line. Dito naman, nakalay siya sa vertically. Dito naman ay nakaslant sa 2p z orbital. Okay. So, these are the shapes of the 3D orbitals. So, mapapansin nyo, so as you look closer, no, hindi yan sila dikit-dikit. So, these lobes are separated by a region of 0 electron na tinatawag na node. Ayan. So, sinaseparate sila ng region na tinatawag na node. So, sa 3D, meron tayong yan, x squared minus y squared, may xy, may xz, may yz, and the z squared. So, the maximum electron holding capacity of the 3D orbital is 10. Okay? Sa 2p, meron siyang, sa p orbitals, meron siyang 6 capacity. Sa d orbitals, meron siyang 10 electron capacity. Okay. So, there's a mnemonic device for electron configuration. Ayan. So, madali na lang siya. So, mapapansin nyo na parate siyang pababa. or pa-slant. Ayan, nakaslant downwards. Ayan. So, 1s, 2s, then after 2s, we have 2p, 3s, then after 3s, we have 3p, 4s, then after 4s is 3d. Okay? It's not 4p. It's 3d. 4s, 3d, 4p, 5s, then 4d, 5p, 6s, and so on and so forth. Okay. So there are rules in electron configurations. So the lowest energy arrangement or the ground state electron configuration of an atom is a listing of the orbitals occupied by its electrons. So we can predict this arrangement by following 3 rules. So we have the Aufbau principle. So the lowest energy orbitals fills up first according to the order 1s, 2s, 2p, and so on. Note that the 4s orbital is between the 4s yan. So the 4s orbital lies between the 3p and the 3d orbitals. Okay. So rule number 2, the Pauli exclusion principle. Only 2 electrons can occupy an orbital and they must be of opposite spin. And ang electrons, umiikot siya as if they were spinning around an axis. It's like kung paano umiikot ang Earth sa axis niya. So this spin can have 2 orientations, the up and down. And pag ganyan siya dapat. Sa Hand's rule number 3, if 2 or more empty orbitals of equal energy are available, 1 electrons occupy each with spins parallel until all orbitals are half full. Okay. So for example, we have meron muna tayong example, the oxygen. So, ang oxygen has a atomic number of 8. So, yan. So, sa first shell, nag-occupy siya ng 2 electrons. Then, the second shell niya, merong 2s and 2p, right? So, sa s orbital, 2 lang. And sa p orbital has 4 electrons instead of 6. So, pag i-diagram ko siya, yung orbital diagram box or orbital box, so we have the 1s here. So, ito yung box niya, diba? Oh, okay, wait. Ang hirap. Ayan. So, dapat may box siya dito. Ayan. So, meron tayong 2s here. So, ganun din. Okay, sa 2p, sorry. Okay, ilan ang orbitals ng p? Meron siyang 3 orbitals ang p. And each should have, sabi doon, ano nga yung sabi doon sa rule number 3? If 2 or more empty orbitals of equal energy are available, 1 electron occupies each with spins parallel until all orbitals are half full. So, we already had 4 electrons. 1, 2, 3, 4. So, 4 na lang. Okay. So, fill daw muna natin lahat ng orbitals and we could go back on the first orbital para magkaroon ng saktong 4. So, that's how you do the electron configuration using the orbital box diagram or the orbital diagram box. Okay? So, on exercise number 3, give the electron configuration for the following atoms. So, you would do this and also this one, the simplified electron configuration and the orbital diagram box. Okay? So now the development of chemical bonding theory. So noon pa man, chemists already began studying the forces that hold compounds together. So si Auguste Kekulé at si Archibald Cooper noong 1858, they proposed that in all organic compounds, carbon is tetravalent. So meaning, carbon forms 4 bonds with other elements para maging stable compound. Okay? So sinabi rin ni Kekulé na ang carbon atoms can bond with another atom to form an extended chain. And also, carbon can double back on themselves to form rings of atoms. Ibig sabihin, pwedeng mag-double bond yung carbon sa isa't isa. So, in 1874, Van't Hoff, Jacobus Van't Hoff and Joseph Lebel added that the 4 bonds of carbon are not oriented randomly, but they have specific directions. So, meaning, may 3D form siya. So, they suggested the tetrahedral carbon atom. Ayan. Ito yung proposed na form nila Van't Hoff at Lebel. And the carbon is at the center. Ayan. Ito daw yun. Now, yung solid lines, ayan, sorry. Ayan. So, the solid lines represent bonds in the plane of the page. Ayan. Ito daw. Yung solid lines represents the bond in the plane of the page. Ibig sabihin, naka-level or even yung page. Naka-straight line lang siya. So, the heavy wedged line, this one, represents a bond coming out of the page towards the viewer. So, papunta daw sa akin. Papunta daw sa viewer. So, that means pababa siya. And the dashed line represents the bond receding back behind the page. So, away from the viewer, itong ating dashed line. So, ibig sabihin, pataas siya. Kasi paalis pa. Parang paano siya eh. Paalis siya away from the viewer. Okay? So, ibig sabihin, this is the carbon. And, ito yung mga nagbaband sa kanya. For example, merong H. Pwede siyang chlorine, ganyan, ganyan. Okay. Okay, there. So, why do atoms bond together? So, atoms bond together because the resulting compound is more stable and lower in energy than the separate atoms. And energy, usually as heat, always flow out of the chemical system when a bond forms. And conversely, energy must be put into the chemical system to break a bond. So now that we created a bond, we describe these bonds electronically. But how? Paano natin malalaman kung positive or negative? So first, aalamin muna natin ang electronic properties of atoms. So, try to remember the noble gases. So, the noble gases are those gases na may 8 electrons doon sa outermost shell nila or tinatawag natin na valence shell. And the octet rule imparts special stability to the noble gas elements like yung sa group 8A na element. Ayan. So, ito yung mga yan, helium, neon, argon. So, ibig sabihin, sa outer shell nila, meron silang saktong 8 electrons. Okay? So, let's have an example, yung ating neon. So, neon has an atomic number of 10. So, pag isusulat natin siya sa ating electronic configuration, sa orbitals natin, 2s, neon is 10, so 1s, 2, 2s2, and 2p4, right? Ayan. 2p6 pala, sorry. 2p6. Para siya ay maging 10, okay? So, pag i-orbital natin siya, okay? So, sa first shell, we have 2 electrons. On the second shell daw, we have 8. Kasi, dalawa sa s orbital. Sa p orbital is 6. 1, 2, 3, 4, 5, 6. So, as you can see, ang outer shell niya, the second shell, has an 8 electrons. So, pasok siya sa, pasok siya dun sa octet rule natin. Let's have the, what do you call this? The argon. So, ang argon has 18 atomic number. So, we already had, we already had 10 electrons, diba? 8 electrons doon sa 2p. So, 1s2, 2s2, 2p6. After 2p6, we have 3s2. And then, after 3s, we have 3p, right? So, 3p6. So, sakto ulit. Okay? So, 3s2, dalawang electrons, then 6 daw sa p orbitals. I'm sorry, lumagpas. 4, 5, and 6. So, dapat yan ay, equally scattered. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So, 8 din ang sa outer shell niya. So, kung kanina, ang outer shell ng neon is 2s2 and 2p6. Ang outer shell ng argon is 3s2, 3p6. Okay? So, pag tinanong ko anong outer shell ng ganito, ng neon, so you would answer 2s2, 2p6. Okay? So, what's the outer shell of krypton? Ganyan. So, you would know what's the outer shell na, ha? Okay. Next. Okay. So, paano naman ngayon yung gases na hindi saktong 8 ang electron sa valence shell nila? So, these elements may either lose electrons or to form a cation or yung positive na may positive charge, or gain to form an ion or yung may negative charge. So, let's have NaCl or Na, sodium, and Cl, chlorine, for example. So, ang Na natin has an atomic number of 11, yung ating sodium. So, pag electronic configuration natin is 1s2, 2s2, 2p6, and that's already 10. So, we have 3s1. Okay? So, ibig sabihin, dito sa outer shell niya, sa third shell niya, ay isa lang yung ating electron. So, that makes our sodium very unstable. Okay? So, ang chlorine naman natin is 17. Okay? Oh, sorry. Okay, 17. So, 1s2, 2s2, 2p6, that's 10. 2s2, that's 12. 3p, 5. Okay, para 17. Okay. So, pag isusulat naman natin siya sa ating orbitals, so 1s2, 2s2, sa third shell, meron siyang 7. 1, 2, 3, 4, 5, 6, 7. So, hindi niya na-meet yung octet rule na dapat 8. So, ang ginagawa is yung ating NaCl, so yung ating NaCl, naglo-lose siya ng electron. Nagbibigay yung ating sodium, nagbibigay siya sa ating chlorine ng electron. Kasi mahirap naman na ang chlorine ang magbigay sa sodium, 'di ba? Kasi ang chlorine kanina ay 7 na rin yung valence electrons niya. Ang valence electrons naman ng valence electron ng sodium natin ay 1 lang. So ang Na magbibigay siya ng electron kay chlorine. So si chlorine magigain siya ng electron. So pag nag-lose ng electron, nagkakaroon ng positive na sign. Pag nagigain naman ng electron, ibig sabihin, nagkakaroon ng negative sign, nagiging anion siya. So, if we combine, pag nag-combine na yung ating sodium at chloride, magkakaroon na tayo ng chlorine, magkakaroon na tayo ng sodium chloride. So, magkakaroon na sila tinatawag na ionic bond. So, ang ionic bond is the bonds between ions of unlike charge. So, that's how we can describe the bonds electronically. Oops. Okay. So, paano naman ngayon yung mga elements that are closer to the middle of the table? Paano naman natin i-describe yung bonds nila? So, for example, we have methane. Okay? So, ang methane, yung CH4, is the main constituent of natural gas. So, ang valence electrons ng carbon is 4. Kasi ang carbon natin ay may atomic number na 6. Okay? So, ang 1s2, 2p2, 2s2, 2p2. Okay? So, meron siyang 4 valence electrons. 1, 2, 3, kanya lang yan. 4. Okay. So, carbon would take too much energy para mag-gain siya or mag-lose ng 4 electrons para ma-achieve yung ating noble gas configuration. So, ang carbon ngayon, magbaband na lang siya with other atoms. Mag-share na lang siya ng electrons. So, pwede siyang mag-band with hydrogen, ayan, mag-band siya with chloride, o ng chlorine, pwede siyang mag-bond with, nitrogen, ayan, pwede siyang mag-bond ganon. So, this shared electron bond is called the covalent bonds. So, ang covalent bonds, it was proposed by G.N. Lewis on 1916. So, when we combine atoms with covalent bonds, tinatawag na natin siyang molecules. Okay? So, a simple way of indicating the covalent bonds in molecules is to use what we call the Lewis structures or the electron dot structures. Sa electron dot structures, the valence shell electrons of an atom are represented as dots. So, ang ating hydrogen, 1 lang kasi naman siya. So, ang valence electron niya ay 1 lang, diba? 1s1. Ganyan siya. Okay. Okay. Dito naman sa ating carbon, meron siyang 1s1, 2s2, 1s2, 2s2, 2p2. So, sa ang outer shell niya is 2s2 and 2p2. So, that makes 4 electrons ang kanyang valence shell. So, in this case, yung carbon natin, meron siyang, 1, 2, 3, 4 valence shell. And ito yung hydrogen, represented by the green. Yung carbon is dark green. Itong light green naman ay ang hydrogen natin. So, ang valence shell niya yun. Itong light green na isa. So, that's the Lewis structure. Okay? So, carbon has 4 4 dots, no? Ang nitrogen natin has 5 dots kasi ang nitrogen, ang kanyang number ng nitrogen ay 7. Ayan, 7. So, 1s2, 2s2, 2p3. So, ang outer shell niya is 2s2, 2p3. So, that makes 5. 5 na electrons. Ayan, yung blue. 1, 2, 3, 4, 5. Ayan. So, oxygen has 6 dots. Kasi ang outer shell niya ay 2s2 and 2p4. 8 ang kanya atomic number and so on. Okay? So, magiging stable lang ang molecule kung ma-achieve ang noble gas configuration for all the atoms. So, 8 dots yon for main group atoms or 2 dots for hydrogen. So, merong mas simple naman which is the Kekulé structures or the line bond structures in which 2 electron covalent bond is indicated as a line drawn between the atoms. So the number of covalent bonds an atom forms depends on how many additional valence electrons it needs to reach a noble gas configuration. Okay. So this one, sa ating hydrogen, meron nga lang siya isang valence electrons and thus needs one more to reach the helium configuration which is 1s2. So it forms one bond only. Yung carbon naman, meron siyang 4 valence electrons and needs 4 more to reach the neon configuration which is yung 8, diba? Which is 8. Ayan. So, ang nitrogen has 5 valence electrons and needs 3 more para mag-form siya ng 3 bonds. Ang oxygen, 6 yung kanyang valence electrons. So, meron ng partner yung dalawa. So, dalawang bond lang ang pwede niyang magawa. So, ayan. And yung methanol natin, we have yung oxygen natin, nakaband sa carbon and nakaband sa isang hydrogen. So, that makes a stable molecule. Okay. So, valence electrons that are not used for bonding are called lone pair electrons. So, or yung mga non-bonding electrons. So, the nitrogen, yung kanina, yung sa ammonia natin. So, the nitrogen atom in ammonia, for instance, shares 6 valence electrons in 3 covalent bonds. Tatlo lang naman yung ginawa niyang covalent bonds. And has its remaining 2 valence electrons in a non-bonding lone pair electrons. So, as a time-saving shorthand or non-bonding electrons are often omitted, okay, when drawing a line bond structures. But we still have to keep them in mind since they're often crucial in chemical reactions. Ayan. So, nawawala na hindi na natin nilalagay yung lone pair electrons. Basta nila-line bond na lang din natin siya minsan. Okay. So, in exercise number 4, predict the number of bonds formed by an atom. So, number 1, how many hydrogen atoms does phosphorus bond to in forming phosphine? So, ilang hydrogen dapat ang meron kumabit doon sa ating phosphorus para maging stable siya. Sa aluminum natin, ilan ba yung kailangan niyang hydrogen para ma-meet niya yung octet rule? At ganun din sa carbon chloride. So, ilang chloride ang meron mag-bond sa carbon para maging stable at ma-meet yung octet rule natin. Okay. So, in exercise number 5, draw the electron dot and line bond structures of the chloromethane and the hydrogen sulfide. And kung meron mang lone pair electrons, kailangan yung i-indicate yon yung lone pair electrons. Okay. So next topic is describing the chemical bonds, the valence bond theory. So how does electron sharing lead to bonding between atoms? So there are two models to describe the covalent bonding of atoms, the valence bond theory and the molecular orbital theory. But we will focus more on valence bond theory on this lecture. So a valence bond theory states that a covalent bond forms when two atoms approach each other closely and a singly occupied orbital on one atom overlaps a singly occupied orbital on the other atom. So for example, yung ating hydrogen. So sa s orbit nila, meron lang silang isang atom, isang electron, 'di ba? So mag-overlap yung isang hydrogen atom doon sa isa pang hydrogen atom. So their available electrons will pair to each other and will have an H2 molecule. So magkakaroon tayo ng H2 molecule. So these overlapping orbitals in the H2 molecules have elongated egg shape. So parang para siyang egg. So the head on bond between H2 molecules is called sigma bond. Okay. So meron daw bond na sigma bond. Okay. So earlier, we said that whenever we bond two atoms, we release energy. And when we break bonds, we apply energy. So this energy is called the bond strength. So the bond strength describes how strongly each atom is joined to another atom, and therefore the amount of energy required to break the bond between that two atoms. So for example, we have two hydrogen atoms and we want to combine that. So when we combine two hydrogen atoms, we release 436 kilojoules per mole. So magkakaroon tayo ng H2 molecule. So when we want to break that H2 molecule into two hydrogen atoms, we also need 436 kilojoule per mole to break that bond. So that's the bond strength. And meron din tayong ideal distance for two nuclei atoms to be able to bond. So this distance is called the bond length. So if two atoms of hydrogen, for instance, are too close, they will repel each other kasi para silang positive. If they are too far naman with each other, they cannot share their electrons with each other. So the ideal bond length for the H2 molecule, the two hydrogen atoms, is 74 picometers. So that's so the bond between two hydrogen atoms is very simple and straightforward. Pero paano naman ngayon yung mas complex na examples such as these compounds, so these molecules? So the CH4, the methane, the double bond, and the triple bond. So how does valence bond theory explain the bonding behavior among these structures? So meron tayong tinatawag na hybrid orbitals. So para maintindihan natin yung hybrid orbitals, let's have the concept called the hybridization. So if you take any orbital, in this case we have the s orbital, diba, sphere, and the dumbbell na p orbital, and we put them together, we fuse them together, so magkakaroon tayo ng tinatawag na hybrid orbitals. Ayan. So that's what you call hybridization. So, mas malaki yung isang lobe kasi syempre ito ay ang ating s orbital is positive and this is positive and negative. So, positive plus positive, mas lalaki talaga yung lobe ng positive. Okay? Now, let's see how sp3 hybridized carbons come together. So, ang carbons natin has 6 electrons. That is its atomic number. So, in this matter, we are concerned with its valence electrons, which is 4. So, let me have the energy diagram for carbon. So, this is the energy diagram for carbon, okay? So, 1s2, 2s2, and 2p2. So, that makes 6 electrons. So, 2 electrons doon sa kanyang first shell, sa s orbit ng first shell. Sa second shell, sa s orbit niya is 2 electrons as well. Sa p orbital ay 2 lang at yung isa ay wala. So, what happens is, so itong isang arrow isang electron doon sa s orbital sa 2s2 ay mapupunta doon sa p. Okay? So magiging ganito na siya. So magiging ganyan siya. And this one also magiging ganon. Ayan. So, magfufuse na ang s orbital at ang p orbital. So, magkakaroon na ngayon ng sp3 orbital. So, paano naging 3? Kasi 3 types of p orbitals ang involved doon sa ating hybridization. So, the py, the px, the pz, diba? So, these are all sp3 hybridized orbital and they are more stable. So, they have stronger bonds kesa doon sa mga unhybridized s or p orbitals. Then, the hydrogen, this one, ito, hydrogen yan. So, the hydrogen will come along and forms a bond with the carbon, supplying an additional electron to make it stable. So, ito, pupunta, magbaband dito, another hydrogen magbaband din dito, here and here. Okay. So, that's the sp3 hybrid orbitals of methane. So, the above, the image on this one is the schematic diagram of the sp3 orbitals. And as you can see, hindi naman talaga siya even. So, they are unsymmetrical. Kasi, di ba nga, magkaiba ang charge ng lobes ng p orbitals. May positive and negative. So, when a p orbital hybridizes when an s orbital, yan. So, nag-a-add ngayon yung ating positive sign doon sa positive lobe ng p orbital doon sa ating s orbital. Okay. So, this is how covalent bonds exist in sp3 hybridization and how methane structure is formed. So, so this is the molecular structure of the methane. Ayan siya. So, as you can see, yung bond length niya daw is 109 picometers and the band angle is 100.5 degrees. 109.5 degrees, I'm sorry. Okay. So, now that we learned how hybridization happens on methane that has only 1 carbon, paano naman yung may 2 carbons or may 3 carbons and so on? So, the same kind of orbital hybridization that accounts for the methane structure also accounts for the bonding together of carbon atoms into chains and rings to make possible millions of organic compounds. So, let's take ethane. So, ang ethane has 2 carbons. So, imbes na hydrogen ang mag-bond dito sa isang orbital niya, so the second carbon shared its electron doon sa ating first carbon. So this carbon, ayan, so this covalent bond, so this covalent bond is a sigma bond kasi sa top or sa head part siya ng lobe ng fuse. Ayan, ganyan siya. So, there. So, the bonds we've seen in methane and ethane are called single bonds because they result from sharing of one electron pair between the bonded bonds. However, it was recognized nearly 150 years ago that carbon atoms can also form double bonds by sharing two electron pairs between atoms. So the hybrid orbitals involved in the double bonds is the sp2 hybrid orbitals. So when two carbons with two sp2 with sp2 hybridization approach each other, they form a strong sigma bond by sp2 head-on overlap. Ayan. So nagkakaroon sila ng overlap dito banda, doon sa kanilang sa taas. So sa sp2 head nila. So at the same time, yung mga unhybridized p orbitals nagkakaroon din ng overlapping. Sideways naman yung overlapping nila. Kaya nagfo-form tayo ng tinatawag na pi bond. So, the electrons in the sigma bond occupy the region in the center. Ito yung sigma bond. So, between the nucleus. So, ang electrons naman ng pi bond ay doon sa taas at sa baba ng ating nucleus. So, that's the sp2 hybrid orbitals. So, in sp naman, hybrid orbitals, sa single bond, atoms share 2 electrons. Sa double bonds, 4. So, dito sa sp hybrid orbitals natin, ang carbon natin can form a triple bond by sharing 6 atoms. So, mayroon siyang 6 atoms na sinishare. So, this is a diagram of acetylene, yung C2H2 pala yan, C2H2. And acetylene ay merong triple bond. So, meron siyang isang sigma bond sa gitna at dalawang pi bonds. So, that's the different sp hybrid, the hybridization or the hybrid orbitals. We have the sp3, which is single bond, the sp2, the double bond, and the sp, which is the triple bond. Okay. Exercise number 6. Draw an electron dot and line bond structures for the following molecules and indicate the hybridization of the orbitals on each carbon. So, for example, kunyari, where is that? Okay. Oops. Kunyari, this one. So, meron, kunyari, akong CH. Oops. Wait lang. So, meron akong CH3, then CH2, then CH double bond. Okay, double bond C, and double bond C, and H2. Okay. Okay. So, I would draw a line bond like this. C. Okay, I would draw first the C's. 1, 2, 3, 4, 5. So, I have 5. On the second, ayan. Third, I have a double bond on the third carbon and double bond on the fourth. So, I'll just fill that out with hydrogen. So, I have 3 hydrogens here, hydrogen atoms. I have 2. And on this one, I only have 1. Why? Because carbons forms 4 bonds only. So, meron na siyang double bond dito, 2, 3, and 4. So, isa na lang kailangan niya talaga, isang H. And this one, wala na, kasi wala naman siyang H. And this one, I just need 2 hydrogens to form a stable compound. So, that's the line bond for this compound. Okay, 1, 2, 3, 4, 5. So that's pentane. Okay. Now, if I want to draw, oops. Wait. Okay. So if I want to draw a line, electron dot. So I have 5 C's, 2, 3, 4, and 5. Okay. Oops. Okay. So my carbon has 4 valence electrons, right? 1. Oops. Yeah. Paano ba yun? Forgot. 1. Oops, that's 2. Thick. Okay, I have 1, 2, 3, and 4. And also this one, 1, 2, 3, and 4. And on this second one, I have also 1, 2, 4, 1, 2, 3, 4. Okay, hindi na siya pantay-pantay. Okay. So, hydrogen, I would go for yellow. Wait lang. So, I have, oops. Hydrogen here, hydrogen here, hydrogen here. Okay. So, meron siyang electron there. So, dito, wala na siyang electron, right? Kasi nag-share na ang dalawang carbon. So, dapat pala ay nakaganito siya. Ayan. Ba't ayaw ayan. Hirap. Okay. Oops. Basta that na yan. Okay. So, another one. So, I have H here. Okay. And also here, sharing 1 electron with the carbon. So, this one, it also should be, ayan, vertical, horizontal pala. And on this one, on the third carbon, I only have 1 hydrogen atom sharing 1 electron. So what happens is this carbon atom will be erased. That electron will be erased and put it here. Just yan. And also, syempre, siya din, magbibigay din siya ng isa. Ano ba yan? Bakit yun? So, magbibigay siya ng isa dito. Okay? That's 1. So, we will erase this one. And, ayan. So, ang sabi din dito sa ating, sa ating fourth carbon, ayan, is double bond din siya. So, magbibigay siya dito ng isa pang electron. And then, let's erase that. And this one also, mag-erase din tayo ng isa. Mag-erase din tayo ng isa at bibigay natin dito. Ayan. So, ngayon naman, I'll fill that out with our 2 hydrogen atoms. Ayan. So, that's the electron dot structure of that pentane. Okay? So, paano ko naman ngayon sasabihin kung sp siya? Okay, this one, and the first, isa lang naman siya, single bond lang siya, so that's sp. This is also sp, and this is a double bond carbon, so that makes it sp2, sp3 pala itong single bond, sorry, single bonds sp3. So this one ay sp2, also this one is sp2, and the last one, yan ay sp2 and sp3, I mean. Okay, so sp3, sp3, sp2, sp2. This one is a combination of on the last one. Ay, bakit yun? So on the last one, this one, meron siyang combination of sp3 and sp2. Also this one. Kasi may single bond siya sa carbon dito at may double bond siya sa dito. So that's a combination of sp3 and sp2. Oh. Sana naintindihan nyo. Okay. So, there you go. Ayan. So, draw the electron dot and line bond structures of the following molecules and i-indicate nyo yung hybridization ng mga carbons. Okay? So, next, convert the following molecular model of hexane, a component of gasoline, into a line bond structure. Kahit line bond na lang dyan. But if you would also give the electron dot structure, I would give you plus points. Okay. So our next topic is about how to draw the chemical structures. So we have ways to draw chemical structures, and yung mga structures na ginawa natin on the previous previous topics. So in the covalent bonds, meron tayong, 'di ba, dalawang electrons ang meron sa line doon sa between atoms. Kanya we have C here and a line between two C's, okay? Now, sa bawat line, ibig sabihin, at the end to end, meron tayong two electrons na sinishare ng dalawang carbon. Okay. So, drawing every bond and every atom is tedious. Diba? Nakakapagod. However, yung mga chemists natin, they have devised several shorthand ways for, for writing structures. So, we have the condensed structure. So, in condensed structure, carbon-hydrogen bonds, this one, carbon-hydrogen bonds and carbon-to-carbon single bonds aren't shown. Okay? So, ito, nagiging ganito na lang, yung ito, nagiging CH3 na lang. So, ayan. So, they are understood instead. So, if a carbon has three hydrogen bonded to it, so we would write CH3. Okay? Pag dalawa namang carbon ang nakabond doon, we would write CH2. Okay? And kung isa lang naman, we would write CH, and so on and so forth. So, the compound called 2-methylbutane, for example, is written as like this. Okay? So, on the first carbon, meron siyang tatlong hydrogen. So, we would write it as CH3. On this one naman, dalawa, CH2. And then, on the third carbon, okay, sorry. So on the third carbon, we have 1 hydrogen. So you would 1 hydrogen. And on the third carbon, may nag-branch tayo na isa pang carbon. And that carbon has 3 hydrogen atoms. So we would write CH3. And then the last one also has 3 hydrogen attached to carbon. So we would write CH3. So this is the condensed structure of 2-methyl-butane, and you can write it as like this, okay? Okay. So meaning, so CH2 what do you call that? 2 molecules of CH3 is attached to the third carbon, okay? So that's the condensed structure. So another way is this, to draw the chemical structure is the skeletal structure. And there are rules in drawing skeletal structures. So in rule number 1, carbon atoms aren't usually shown. Okay? So instead, a carbon atom is assumed to be at each intersection of 2 lines or bonds and at the end of each line. So we have this isopropene, okay? So every end ng line and every intersection ay carbon yan. So 2 lines, ibig sabihin double bond. So we have this, ito yan siya. Ayan siya, yan, dyan siya. Okay? And on this one, dito sa dulo, ayan, and so on and so forth. So that's the skeletal structure. So rule number 2, because carbon always has a valence of 4, so meron siyang valence electrons na 4, so we mentally supply the correct number of hydrogen atoms for each carbon. So hydrogen atoms bonded to carbon aren't shown. So we take the isopropene again as our example. So dito, may C yan, may carbon dyan, and then it's automatically known na may hydrogen na naka-attach sa kanya. Okay, so depende kung ilan yung free valence electrons ng ating carbon. So rule number 3, atoms other than carbon and hydrogen are shown. Okay? So, doon sa rule number 2, hydrogen lang ang hindi sinushow na nakabond sa carbon. But, kung ito ay, for example, this is not H. That is not H. For example, this is chlorine. So, we would write here, like this one, a line, and then we would write Cl. Okay, so that's how we write the other carbons at other elements or other atoms attached to carbon. Okay, so what if this one is not CH2, but rather that is oxygen? Okay, so I would write here oxygen. Okay. I hope that you understand that. Another examples are this one. So methyl cyclohexane, ayan. So that's that's an easy example, ayan. So it's already understood that every intersection and every end of the line is a carbon, and there are hydrogen attached to it. So, and there's no other elements attached to the carbons. So we would not write any H here. Okay, as another example is our phenol, and as you can see, phenol has double bonds, no? So in-indicate din yan dito, and meron din siyang hydroxyl group, okay, na naka-attach dun sa isang carbon. So the hydroxyl group is shown or is indicated, okay? Now, we would now, so from the skeletal structure, we will try to interpret the line bond structure, or the skeletal band structure. So for example, we have this carvone. So a carvone, a substance that is responsible for the odor of spearmint, has the following structure. So we would tell how many hydrogens, we would interpret how many hydrogens are bonded to each carbon, and give the molecular formula. Okay, so let's have this one first. So on this one, we have letter C. We have a carbon there, and carbon has four free electrons or valence electrons. So nag-form na siya ng isang bond. So, how many bonds, how many hydrogens ang kailangan niya para maging stable? So, we have 3 hydrogen atoms. Okay? So, on this one also, sa intersection, we have letter C. So, ang bonds niya is already 4. 1, 2, 3, and 4. So, wala na siyang kailangan na hydrogen. Okay? On this one, we have letter C. Ibig sabihin nito, naka-double bond na yung this C to our C on the end of the line. So, 2 bonds na lang ang natitira sa kanya. So, this is CH2. Okay? So, this one is carbon. And makikita natin na meron na siyang 3 bonds, covalent bonds na nagawa. So, meron na lang siya isang H for it to be stable. And also, this one is letter C. May 2 bonds. So, 2 hydrogen na lang. And this one also has 2 bonds. So, 2 hydrogen na lang din. Ayan. And this one naman, it already has 1, 2, 3. So, isang H na lang din. And on this one, letter C. So, double bond siya. 1, 2, 3, 4. So, no more H to be attached. This one naman, isang bond lang. So, it requires 3 hydrogen bonds. Okay? On this bond naman sa intersection natin, it already has 4 bonds. So, wala na. On this one naman, naka-indicate na rin naman ng letter O, or yung oxygen, naka-attach doon sa line. So, meaning yung oxygen ay double bonded to the carbon. Okay? So, now, the molecular formula of the carbon is C10H15O. So, 10 daw yung carbon. Let's try. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So, 15 daw yung hydrogen. Let's count. 3 plus 2 is 5. We have 1 here, 6, 8, 10. Okay, 10, 13. Oh, mali. Dapat pala, this is 14, not 15. Okay, and then 1 O. 1 oxygen. So, that's how you interpret a skeletal structure and give the molecular formula. So, in your last worksheet for the lesson 1, interpret the line bond structure and give its molecular formula. So, just how we did it on the last slide. Okay. Yeah. Another one is drawing the skeletal structure of the following molecular models and give its molecular formula. So, the red ones, okay. So, the red circles are oxygen. Okay, that's oxygen. And the blue one, this one, is nitrogen. And the black ones are carbon. Okay. And these white ones are hydrogen. So, draw the skeletal structure of this PABA or the PABA and give its molecular formula. Okay, so that ends our lesson number 1. Hope you understood my lessons or this topic. Okay.